These are the last two questions out of our homework set 45 on sequences. Question 14 says we're given this sequence here and we want to find the 8th term and the sum of the first 8 terms. So first of all, what kind of sequence is this? Maybe I'm just going to ask. I don't know yet. What if it's arithmetic? Okay, if it's arithmetic, that means like 9 minus negative 3 would be 12, and then negative 27 minus 9, well, that's negative 36, so it is not arithmetic because I don't get the same common difference. Is it geometric? Geometric. Take the 9 divided by negative 3, I get negative 3. Now take the negative 27 divided by 9, I get negative 3. Let's just be sure. 81 divided by negative 27, negative 3. All right, so it is geometric. And I have formulas for the nth term of a geometric and the sum of the first n terms. So here's what I know for the nth term. I know that for a geometric, a sub n is equal to a1 times r to the n minus 1. Now in this case, I want a sub 8. So that's going to be the first term, which is negative 3 times r. Now r we got up here when we were playing around with this. R is negative 3. And I want that to the 8 minus 1. So this is negative 3 times negative 3 to the 7th. Or actually, then, all right, so negative 3 times, this is negative 2187. Multiply that by negative 3 again, times negative 3, and I get 6561. 6561. All right, so that's a sub 8. So I will note that up here at the top. This is 6561. Now we need the sum of those first 8 terms. I have a formula for that. It goes like this. It's a fraction. It's a1 times r to the n and then minus 1 all over r minus 1. Let's substitute. S sub 8 is, right, first term negative 3, and then, careful with these negatives, negative 3 to the 8, and then minus 1, all over negative 3, that's r, minus 1. And this will give us negative 3 times, now negative 3 to the 8, you might want to do that on your calculator. So on your calculator, just down here at the bottom right, parentheses, negative 3 caret 8. All right, so when I did that, I got 6560. Actually, I got 6561. That's actually what we got from the last problem. And then minus 1 all over negative 4. Now I'll do it top right here. This will give us negative 3 times 6561 minus 1 is 6560 over negative 4. Now multiplying that top together, I got negative 19680, negative 19680 over negative 4. And then finally, when I divide that by negative 4, I get the sum of the first 8 terms to be 4920. 4920. There we go, and I will put that 4920 right there. Our last question here, 15, says that we're given this sequence, and we want to find the 9th term and the sum of the first 9 terms. So what do you think about this sequence here? Is it arithmetic or geometric? Now, arithmetic means that I can get from one term to the next one, just by adding or subtracting some number. Now, how do you get from 16 to 8? Well, you could subtract 8. But then how do you get from 8 to 4? Well, you subtract 4. And so it's different, right? I'm not subtracting the same number. But well, maybe it's geometric. Now, how do I get from 16 to 8 if it's geometric? I could divide by 2. Divide by 2, divide by 2. Or actually, I'm multiplying by 1/2. So what I'm going to say here is that this is geometric with A1 equal to 16 and R equal to 1/2. Now I have formulas for the nth term of a geometric sequence. That's this one right here. It says the nth term is the first term times the common ratio to the n minus 1. Now let's see what that does for us. We want the ninth term, right? So we have, can't see it up there, n is equal to 9. So we'll get a sub 9. The ninth term is a1, which is 16, times r, which is 1/2 to the 9 minus 1. How about 16 times 1/2 to the 8th? That's going to be 16 times 1 over 256. Now, I just happen to know that 16, all right, it's this, 16 over 256. 16 will go into 16 once, and to 256 16 times. This turns out to be 1/16. All right, so the ninth term of this geometric sequence is 1 over 16, 1/16. Now, the formula for the sum of the first n terms is this one here. It's a fraction. It goes like this. A1 times r to the n minus 1 over r minus 1. Now, with n equal 9, we'll get s sub 9 is equal to the first term, 16, times r. Now, r is that, I'll put it in parentheses, 1/2 to the n, this is 9, and then minus 1, all over r, which is 1/2 minus 1. So this will give us 16 times, now 1/2 to the 9th is 1 over 5/12 minus 1, all over 1/2 minus 1 is negative 1/2. Now for this numerator, I'll do this up here. S sub 9 is equal to, or we're going to get to 16. Now what we're going to get here is 1 over 5/12 minus 1, but I'm going to write that 5/12 over 5/12 all over negative 1/2. So this will give us 16 times, now this will be 1 minus 5/12 is minus 5/11 over 5/12 divided by negative 1/2. Now, it turns out that 16 will go into 16 once. It'll go into 5/12 32 times. So now I'm left with this. Negative 5/11 over 32 divided by negative 1/2. So this will give us negative 5/11 over 32 times negative 2 over 1, right? Invert and multiply. And now I get negative negative is positive. I get 5/11 over 2 into 2 is once, 2 into 32 is 16. All right, that is the sum of the first 9 terms. I'll write that up here. It is 5/11 over 16. Now look, if you're finding this computation cumbersome, it is, no doubt. So when you get back to this point right here, when you have that expression, why don't you go to Wolfram Alpha, right? So you go to Wolfram Alpha. So you go to www.wolframalpha.com. This screen comes up, and now what you want to do is evaluate. So type in evaluate, tell it what you want to do. Evaluate this. Now it's a fraction, so I'm going to capture all of it. I'll do it down here where we can see it. I'm going to write this. Here's what I'm going to type in. Okay, parentheses to catch the top. 16, and then another parentheses, 1/2, close, raise that to the 9th, then minus 1, close the parentheses. Now, close the top, right? These set off the top. Divided by, now parentheses, 1/2 minus 1. Now I did that, and here's what I got, right? Here's my evaluation right here. Wolfram Alpha tells me what it thinks I put in. Yeah, that's what I wanted. And here's the exact result, all right? So there's really, you get to something like this, some kind of computation like this. There's no need for us to do that arithmetic. That's not what we're here for. So let the machine do that cumbersome part, and we'll just know what to do and get the right answer and interpret it. That ends our homework set 45.